Despite staggering growth over the past decade, the global solar photovoltaic market is entering a period of transition. Market analysts are cautioning that near-term headwinds, from oversupply and pricing pressure to policy uncertainty and trade barriers, are reshaping the competitive landscape. Yet the industry's long-term fundamentals remain strong, anchored by cost competitiveness, rising demand in emerging markets, and deeper integration of energy storage. Solar power isn't just another form of electricity generation. It represents a cornerstone of the renewable energy transition, the shift away from fossil fuels toward cleaner, sustainable sources. Solar PV systems capture energy from sunlight and convert it into electricity using semiconductor materials such as silicon. Its fuel-free nature shields it from fluctuations in oil, gas, and coal prices and makes it resilient against the geopolitical risks that typically affect fossil fuels. In this report-style exploration, we'll unpack the current state of the solar market, the pressures it faces, where growth is emerging, and what this means for utilities, investors, policymakers, and everyday energy consumers. Before diving into the industry's current challenges, it helps to understand the scale and structure of the solar market. As of the early 2020s, cumulative global solar PV capacity surpassed 1.6 terawatts, producing thousands of terawatt-hours of electricity annually. China dominates global solar manufacturing, responsible for over 80% of module production capacity. Falling costs, climate goals, energy security concerns, and electrification of sectors such as transportation and data centers continue to support demand. With these fundamentals in mind, let's examine the near-term pressures reshaping the solar industry. One of the most persistent challenges facing the solar market today is oversupply. Manufacturing capacity for PV modules, the heart of any solar system, has expanded rapidly, particularly in China and increasingly in Southeast Asia. Analysts estimate that global manufacturing capability already exceeds projected demand for installations by a significant margin through the mid-2020s. Oversupply occurs when production capacity outpaces real demand for products. In this case, solar modules and upstream components like polysilicon and wafers. While increased production typically drives innovation and lower costs, too much supply can suppress prices, squeeze margins, and prompt businesses to cut production or exit the industry altogether. Average international module prices have stayed below $0.09 per watt, which is low compared with historical levels. Manufacturers, especially in upstream segments like polysilicon and wafers, find it hard to pass increased input costs downstream. Developers and buyers resist price increases, forcing suppliers to absorb costs. In 2025, materials such as silver, a key raw input in many PV modules, saw noteworthy price increases. Because silver contributes materially to module efficiency and performance, rising costs here can affect overall manufacturing economics. Solar industry economics are often discussed using two important concepts. Balance of system costs include everything in a solar project other than the modules themselves: inverters, wiring, mounting hardware, site preparation, permitting, and labor. As module prices have declined significantly over the years, balance of system costs now represent a larger share of total system costs. The levelized cost of electricity is a common metric used to compare the long-term cost of power from different generation sources. LCOE accounts for initial investment, operating costs, system lifetime, and energy produced. Falling module prices have reduced LCOE for solar dramatically, in many regions making it the least cost option.